A civilization with no computers solved a problem that still breaks modern search engines. The Library of Alexandria had no keyword search, no algorithms, no electricity, and yet its cataloging system was so effective that versions of it are still the backbone of how libraries, and arguably how AI models, organize knowledge today. How did people with scrolls and ink out-engineer a problem we're still throwing billion-dollar AI labs at? That contradiction is what this video is going to unpack. Picture the Library of Alexandria at its peak. Somewhere between 400,000 and 500,000 scrolls, all gathered under one roof by order of the Ptolemaic kings of Egypt. Ships docking in the harbor were required to hand over any books on board to be copied. Scholars traveled from across the Mediterranean just to read what was stored there. Now imagine you're handed the keys to that building and told to find one specific scroll. Maybe it's the one where Aristotle writes about friendship. There's no catalog, no index, no search bar, just hundreds of thousands of papyrus rolls, stacked without labels, arriving faster than anyone could track them. You could spend your entire life searching and never find it. This is the trap that shows up every time a civilization or an organization accumulates more knowledge than a single mind can hold. Having information and finding information turn out to be two completely different problems. The gap between them isn't about how much you know. It's about whether you built a way to reach it again. That same trap exists today, just wearing different clothes. A modern AI system can be trained on hundreds of billions of words, more text than any human could read in 1,000 lifetimes. But technically containing an answer and reliably producing that exact answer are not the same thing. More data without a way to navigate it is just a bigger version of the same unlabeled room. The first fix was almost embarrassingly simple. A scholar named Zenodotus, the library's first head librarian, decided to shelve the scrolls in alphabetical order. That sounds obvious now, but it had never been done before at this scale. According to classicist Lionel Casson, this was the earliest known use of alphabetical order as a system for organizing information. Before Zenodotus, there was no established method. Scrolls were just placed wherever there was room. Alphabetizing helped, but it wasn't enough. A library holding hundreds of thousands of scrolls needed more than one sorting rule. That's where a poet named Callimachus of Cyrene came in. Callimachus set out to build something no one had attempted before, a complete written guide to the entire library. He called it the Pinox, meaning tables. It ran to 120 scrolls on its own, about 5 times the length of Homer's Iliad, just to describe what the library contained. The Pinox did something genuinely new. It didn't just list titles. For every work, Callimachus recorded the author's name, a short biography, the genre it belonged to, and 2 details that mattered more than they might seem: the opening line of the scroll and its exact length in lines. Those 2 details worked like a fingerprint. If 2 scrolls had similar titles, or if a scribe had copied a title incorrectly, the opening words and the line count let a scholar confirm they had the right one, not just something close to it. This is worth sitting with for a moment. Callimachus wasn't just sorting scrolls into piles. He was building a layered system, broad category first, like poetry or philosophy or medicine, then a narrower subject within that category, and finally a unique identifier that could verify a match. That's a structure, not just a list. There's a second piece to this story that often gets left out. Zenodotus didn't only organize the collection, he also worked to fix it. Copying scrolls by hand for centuries had introduced errors into the text of Homer's poems. Zenodotus compared different versions against each other, trying to strip away the mistakes and restore something closer to the original wording. In other words, the ancients weren't only asking, "Can we find this scroll?" They were asking, "Can we trust what's written on it once we do?" Retrieval and accuracy were treated as 2 parts of the same problem, not separate concerns. Now shift forward more than 2,000 years. A modern AI language model faces a version of the same problem, except at a scale Callimachus could never have imagined. These systems are trained on text pulled from books, articles, and websites across the internet, amounting to hundreds of billions of words. No human librarian could read through that volume, let alone write a 120-volume guide to it by hand. The old method simply doesn't scale. So engineers built something different. Instead of tagging each piece of text with a category written in words, the system converts information into what's called an embedding. This is a mathematical representation, a long string of numbers that captures the meaning of a word, sentence, or document. The key idea is that pieces of information with related meanings end up positioned close together in this mathematical space, while unrelated ideas sit far apart. Finding relevant information stops being about matching a label. It becomes about measuring distance between points in this space. This shift gave rise to a technique called Retrieval-Augmented Generation, often shortened to RAG. Instead of relying only on patterns memorized during training, a RAG system pairs a language model with a separate, searchable index of documents. When you ask a question, the system first searches that index for the passages most relevant to your query, based on how close they sit in that mathematical space. Then it hands those specific passages to the language model to generate an answer grounded in them. Look at what this is actually doing. It's performing the same function as Callimachus's incipits and line counts, just using very different tools. The opening words of a scroll confirmed a scholar had the right one. A similarity score in an embedding space confirms the model has pulled the right passage, not just something that sounds related. Both systems are solving the identical problem. How do you confirm a match instead of just guessing at one? This also reframes what people mean when they talk about an AI system being smart. A large language model isn't just a giant container of memorized facts. A significant part of what makes it useful is the retrieval architecture built around it, the mechanism that decides which piece of information gets pulled forward at the right moment. Scale alone doesn't solve the problem. The Library of Alexandria already proved that. What solves it is a system built specifically to search, verify, and retrieve. Strip away the papyrus and the vector math, and both systems are running the exact same underlying process. First, sort the raw material into categories. Second, attach some kind of identifying detail to each piece. Third, build a way to match an incoming question to the right category and confirm that the match is correct. Alexandria did this with genre, then incipit and line count, then a librarian's own knowledge of the shelves. Modern AI does this with embedding clusters, then similarity scores, then an automated search across an index. Different materials, same 3 steps. Seeing that shared skeleton makes the similarities easier to name. Both systems treat verification as non-negotiable. Callimachus didn't just want scholars finding a scroll, he wanted them finding the correct scroll, which is why the incipit mattered as much as the title. A modern retrieval system does the same thing by scoring how closely a passage matches a query before handing it over. Neither system treats close enough as good enough on its own. Both systems also prove that raw accumulation is worthless without structure. Alexandria's scrolls sitting in an unsorted pile were not a resource. They were a liability, taking up space and giving false confidence that the knowledge was accessible when it wasn't. The same is true of a language model's training data. Simply having ingested billions of words guarantees nothing about being able to locate the right one on demand. And both systems required a division of labor that didn't previously exist. Alexandria separated the scholar librarians, people like Zenodotus and Callimachus, from the scribes who copied the scrolls. Cataloging became its own specialized job. Modern AI development does something similar, treating the retrieval system as an entirely separate engineering discipline from the language model itself. Neither the ancient library nor the modern lab could rely on the people producing the content to also be the ones organizing it. But the comparison shouldn't be forced into a perfect symmetry, because the two systems diverge in ways that matter. Alexandria's cataloging logic was fully visible. Anyone literate could open the Pinox and see exactly why a scroll had been classified under a particular genre, with a particular line count. A modern embedding space offers no such transparency. Even the engineers who build these systems cannot fully explain why two concepts end up positioned close together in that mathematical space. One system can be audited by a human. The other, in its raw form, largely cannot. There's also a difference in how each system handles change. The Pinox was a fixed document, updated only when someone manually revised it. A modern retrieval index can be updated continuously, incorporating new information within moments. And the two systems fail differently. Losing the Pinox meant losing the map to the entire library, a single point of failure, and historical accounts suggest a great deal of Alexandria's collection was in fact lost over time. A modern retrieval system tends to degrade more gradually and unevenly, but that gradual failure is also harder to detect and confirm. This points to a pattern that runs through the entire history of organizing knowledge, not just these two examples. Every leap forward in retrieval technology has demanded the same trait. Zenodotus' alphabetical shelving was something any literate person could understand at a glance. The Pinox required scholarly training to use effectively. Card catalogs that came centuries later required a different, but still learnable, set of conventions. Keyword search engines abstracted that further. And embedding-based retrieval in modern AI has abstracted it again, to the point where understanding exactly why a system returns a particular answer is no longer something most users, or even most engineers, can fully do. Each step traded a little more clarity for a little more power, which leads to the actual lesson sitting underneath all of this. Information has never been valuable simply by existing. Its value comes entirely from the structure placed on top of it, the thing that lets someone locate the exact right piece when it's needed. Alexandria didn't fail because it lacked scrolls. It became useful because someone built a way to search them. And the reason people are still building billion-dollar systems to solve this same problem today isn't because the problem is new. It's because retrieval, not accumulation, was always the harder half of the equation. So maybe the real skill was never knowing more. It was building the layer on top of what you know, the thing that lets you actually find it again when it matters. Alexandria had scrolls and incipits. You have folders, tabs, notes apps, bookmarks you'll get to later. So here's the question worth sitting with. What's your personal Library of Alexandria right now? And does it have a Callimachus, or is it just a pile of scrolls? Drop your answer in the comments. I'll read through them.